Hello students, in a previous lecture I discussed mode of failure of the gravity dam, and now I am continuing that part of the failure of the gravity dam, that is crushing failure. A dam, a dam will fail in the compression or crushing by the failure of its material. It means the maximum compressive stress developed should not exceed the permissible compressive stress. So under the full reservoir condition, the resultant forces passes through the base of the dam, and it will act an eccentricity E from the center of the base width. Therefore, the resultant compressive stress diagram caused by the vertical force may be calculated as following three cases. As you can see in the figure, there are two type of forces acting on the gravity: horizontal forces and vertical forces. Where horizontal forces, the algebraic sum of the horizontal forces is sigma h, and the algebraic sum of the vertical force is sigma v, and the resultant is sigma r, which is passing through the base at an eccentricity e from the center of the base of the width. As you can see in the plan, as you can see in the plan, you can see in the plan, the sigma v and sigma h and the resultant forces act at a distance e from the center of the base width. So now there are two type of stresses acting on the gravity dam. One is direct stress and second is binding stress. Where direct stress is equal to sigma d is equal to sigma v by a, where a is the area of the gravity dam, and the value of this area will be b into L, where L is equal to 1. Length of the gravity dam may be taken as 1, because all the forces acting on the gravity dam be calculated as a per meter length of the gravity dam. Now second one is binding stress. Binding stress sigma be m by upon I by into x max, right? So the resultant stress sigma r is equal to direct stress plus minus bending stress, and put the value of this direct stress and bending stress be get in expression sigma b max and sigma b minimum, where sigma v max is equal to sigma v by b upon 1 sigma v by b into 1 plus 6 e by b, which will act at 2, and sigma b minimum is equal to sigma v by b 1 minus 6 e by b, which will act at heel, heel. The maximum stresses, that is sigma v max, will be provided at the end which is nearer to the resultant. Therefore, the resultant, you can see in the figure, the resultant is passing through the toe. So therefore, the maximum stress will be at the toe. Now, as you can see in the figure, the toe, the element of the toe as shown in figure, there are two stresses acting on this dam, that is normal stress and shear stress. Shear stress always act at the base of the dam, and the principal stresses or normal stresses act on the other side of the dam, other side of the toe. You can see in the figure. Now you can see this, the shear stress tau act at the base of the dam, and we have sigma 1 and sigma 2 are the principal stresses acting on the other side of these elements. So to avoid the compression failure, the permissible stresses should be less than this principal stresses sigma 1 or sigma 2, and the shear strength of this gravity dam should be less than the crushing strength of the material. Now, fourth one is tension. Masonry Or concrete gravity dam are not able to withstand tensile stresses. Hence, they are designed in such a way to avoid tension anywhere in the structure. In order to avoid the tension, the P minimum should be 0 or sigma V minimum should be 0, where sigma V minimum is equal to sigma B by V minus 6E by B is always greater than equal to 0. So, whenever we equate this equation equal to 0, we get a value of E should be less than equal to B by 6, where V is the base width of the dam. If E should be less than equal to B by 6, no tension will be developed. Hence, maximum value of the eccentricity should be equal to 1/6 of the base width. In other words, the resultant should always lie within the middle third. Within the middle third, when the resultant passes downstream of the middle third of the horizontal section, it introduces a tensile stress at the upstream edge of the section, and the tensile stresses may cause crack in the dam section, which would result in increase in uplift pressure.